To quickly get up to speed with variable frequency drives, or VFDs, consider several learning approaches. Firstly, explore self-paced learning options. Online courses can be a great starting point. Platforms like Coursera offer courses such as variable frequency drives for industrial applications. Udemy has courses like variable frequency drives for beginners. Secondly, consider ebooks. There are resources like Fundamentals of Variable Frequency Drives by R. Keith Mobley and Variable Frequency Drives: A Practical Guide for Users by Ismail Kassekse. Thirdly, look into immersive learning experiences. Industry training is valuable. Attend workshops or seminars offered by manufacturers or industry associations. Another immersive approach is to shadow an experienced technician. Observe and assist an experienced VFD technician in the field. Hands-on practice is critical. Request access to VFD equipment in your workplace or a training facility to gain practical experience. When you have questions, utilize available resources. Forums and online communities can be helpful. Control.com has a VFD forum, and Engineers Garage offers a VFD subforum. Manufacturers' websites provide information. ABB website can be found at new.com/drive/ and Rockwell Automation's website is located at rockwellautomation.com/n/product/drives motion control/AC drives. HTML. Also, refer to books like the VFD Handbook by Glenn Mazur and Troubleshooting Variable Frequency Drives by Bob Gully. For quick learning, start with the basics. Understand the principles of alternating current motors, motor control, and VFD operation. Focus on practical applications. Learn the typical uses of VFD in industrial settings, such as pump control, fan speed regulation, and process control. Pay attention to safety. VFD involve high voltages and currents, so safety precautions are essential. Seek mentorship. Identify a colleague or mentor who can guide your learning and answer your questions. Technology is constantly evolving, so make an effort to stay informed about the latest VFD developments and best practices. Understanding alternating current motor principles is paramount. Alternating current motors are electromechanical devices that convert electrical energy into mechanical energy. They operate based on the principles of electromagnetism, where a magnetic field is created by passing alternating current through coils of wire. These magnetic fields interact to produce rotational motion. Key components include the stator, which houses the stationary windings, and the rotor, which is the rotating part. Different types of alternating current motors exist, such as induction motors and synchronous motors, each with its own characteristics and applications. Motor control involves regulating the performance of alternating current motors to meet specific application requirements. This includes starting, stopping, speed control, and protection. Various motor control methods exist, ranging from simple on or off control to sophisticated electronic control systems. Starters are used to limit the inrush current during motor starting, while variable frequency drives are used to control motor speed and torque. Protection devices, such as circuit breakers and overload relays, are essential to prevent motor damage from overcurrents, overvoltages, and other fault conditions. Understanding these principles is crucial for working with VFD, as they are used to control alternating current motor speed and torque. VFD are commonly used in industrial settings for various applications. One common application is pump control. VFD can adjust the speed of pumps to match the required flow rate, resulting in energy savings and improved process control. For example, in a water treatment plant, VFD can control the speed of pumps to maintain a constant water pressure or flow rate, regardless of changes in demand. Another application is fan speed regulation. VFD can regulate the speed of fans in heating, ventilation, and air conditioning systems to optimize energy consumption and maintain comfortable temperature levels. For instance, in a large office building, VFD can control the speed of fans to match the cooling or heating demand, reducing energy waste and improving indoor air quality. VFD are also used in process control applications. They can control the speed of motors in various industrial processes such as conveyor belts, mixers, and extruders to maintain precise control over the process parameters. For example, in a chemical plant, VFD can control the speed of a mixer to ensure proper mixing of reactants, resulting in consistent product quality. These are just a few examples of the many practical applications of VFD in industrial settings. Safety is of utmost importance when working with VFD. Firstly, VFD involve high voltages and currents, which can be lethal if not handled properly. Always ensure that the power supplied to the VFD is disconnected before performing any maintenance or troubleshooting. Secondly, VFD can generate electromagnetic interference, which can affect nearby electronic equipment. Ensure that the VFD is properly grounded and shielded to minimize electromagnetic interference. Thirdly, VFD can produce harmonics, which can distort the voltage and current waveforms in the electrical system. Use harmonic filters to mitigate the effects of harmonics. Fourthly, VFD can cause motor overheating if not properly configured. Ensure that the motor is properly sized for the application and that the VFD is configured to protect the motor from overloads and overcurrents. Fifthly, always follow the manufacturer's instructions and safety guidelines when working with VFD. Understanding and adhering to safety precautions is essential to prevent accidents and ensure a safe working environment. Staying updated on the latest VFD developments and best practices is crucial for maintaining expertise in this field. Firstly, technology is constantly evolving, with new VFD models and features being introduced regularly. Keeping abreast of these developments will enable you to select the most appropriate VFD for your application and to optimize its performance. Secondly, industry standards and regulations are also subject to change. Staying informed about these changes will ensure that your VFD installations comply with the latest requirements. Thirdly, best practices for VFD installation, operation, and maintenance are constantly being refined. Staying updated on these best practices will help you to improve the reliability and efficiency of your VFD systems. Fourthly, there are various resources available to help you stay updated, such as industry publications, online forums, and manufacturers' training programs. Take advantage of these resources to enhance your knowledge and skills. Lastly, continuous learning is essential for maintaining a competitive edge in the field of VFD.